So we have learned how to name hydrocarbons that have double bonds and triple bonds, and we've learned how to name hydrocarbons that have branches, and we've learned, how to name them if they have different size branches or multiples of the same kind of branch or something like that, right? So today what we're going to do is we're going to go ahead and we are going to put some of these together, and we are going to look at some more complex hydrocarbons. So let's go ahead and take a look at that. Let's start with this one here. This one has several branches of different sizes. Let's go ahead and try to name this one. First, let's identify our main chain. We could go 1, 2, 3, 4, 5, 6, 7, 8 carbons. Maybe it bends. Let's see, 1, 2, 3, 4, 5, 6, 7. Well, it's not as long as 8. And I don't think there's any way we could look at this to get more than 8. So our main chain will go just straight across here. So it's got 8 carbons in that main chain. The organic prefix for 8. Oct. And then this is an alkane. There are no double bonds and there are no triple bonds. So let's call this octane. Okay. And now we've got to name our branches. Okay. Let's look at where our branches are here. We've got this branch, this branch, this branch, and this branch. Okay. So we've got two different kinds of branches of two different sizes. This one and this one are 1 carbon branches. This one and this one are 2 carbon branches. Okay. Let's think about how should we number the carbons in our main chain. Should we number them this way or should we number them this way? Well, if I go this way, then I have branches on carbons number 3, 4, 5, and 6. If I go the other way, they're on 3, 4, 5, and 6. So either way, I get the same numbers. Let's go ahead and number it this way, starting over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now we're going to name the branches in order of their length. So let's name the shortest branches first. There are 2 that have 1 carbon in them. Okay. The organic prefix for 1 carbon atom is meth, and we're gonna put the suffix for a branch, which is YL. So those are methyl branches. There are 2 of them, so I want to put the non-organic prefix for 2 in front of that, and that is dimethyl. And then let's put the carbon numbers that they come off of. That's carbon number 3 and carbon number 6. 3, 6, dimethyl. Kind of squeeze that in there a little bit. Let's look at the other 2 branches. The other 2 branches each have 2 carbons, right? So the organic prefix for 2 is F, and then the suffix for a branch, YL. And there are 2 of them, so I'm going to put the organic prefix for 2, or the non-organic prefix for 2, which is di. And then which carbon numbers do they come off of? They come off of carbon number 4 and carbon number 5. 4, 5. So this particular compound would be called 3,6-dimethyl 4,5-diethyl octane. Okay, here's another one for us to look at. This one is a little bit tricky because it kind of bends and snakes all over the place. We've got to look at what is our main chain here. We've got to see how many carbons can we get in our main chain. Obviously, it's not just what's in a straight line. So if we start up here, we can get 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in our main chain. The organic prefix for 9 non. Okay, and this one has double bonds in it. So let's see, we have 1, 2, 3, 4 double bonds in there. So remember, in the middle of the word, we need to put the non-organic prefix for how many double bonds they are. And since there are 4, that prefix is tetra. So I'm going to put tetra. And then we need to end the word with either ane, ene, or yne. And since we have double bonds here, we're going to end it with ene. Now we got to decide, we got to put our numbers to show where those double bonds are. We got to decide which way are we going to number it. Should I number it starting up here, 1, 2, 3, 4, and so forth, or should I number it starting down here? If I go this way, then my bonds are 1, 2, 3, 4, 5, 6, and so forth. So numbering this way is going to give me the smaller numbers. So this is bond number 1, 3, 4, and 5. So 1, 3, 4, 5. Okay. And now let's identify our branches. And there's really not much for branches here. It looks like there's lots of branches, but all of these carbons were in the main chain. All we have for branches is that. So which carbon does that come off of? If we were numbering this way, that's carbon number 2. And then there's only one carbon in this branch, so that would be a methyl branch. So we would name that branch 2. So this compound would be called 2-methyl 1,3,4,5 non-tetrene. How about this one here? It's got a couple of branches, it's got a double bond. Let's see if we can name it here. How long is our main chain? It could go 1, 2, 3, 4. We could go 1, 2, 3, 4, or some variation of that. Either way, they're comparable. So let's say 1, 2, 3, 4. And what is the organic prefix for 4? It's bute. Right? Okay, and we have a double bond here. There's just one double bond, so I don't need a middle prefix. But the suffix for the double bond, ene, butene, and then which bond number would that be? Whichever way we number it, 1, 2, 3, or 1, 2, 3. Either way, it's on bond number 2. So my main chain is 2-butene. Now let's name our branches. We have 2 branches here. One right here. One right here. And they both contain 1 carbon. So they are both methyl branches. Well, this one comes off of carbon number 2, and this one comes off of carbon number 3. If I choose to number it the other way, I get the same numbers, carbon 2 and carbon 3. So my numbers are 2 and 3. There are 2 of these branches, so I need to put the non-organic prefix, di, and with 1 carbon atom, they are methyl branches. So this compound would be 2,3-dimethyl 2-butene. How about this one? Can we draw 3,3-diethyl hexane? Okay. First, let's do the Lewis structure, and then we'll do the skeletal structure. Let's start with our main chain. Our main chain is hexane. So I need hex, meaning 6 carbon atoms. So let me draw that first. 1, 2, 3, 4, 5, 6. And ane tells me that there are only single bonds in this one. There are no double or triple bonds. Now I do have branches. I have 2 branches, and they are ethyl branches. So 2 branches that contain 2 carbon atoms, and they both come off of carbon number 3. So here's carbon 1, carbon 2, carbon 3. I have 2 ethyl branches, so 2 that contain 2 carbon atoms, both coming off of carbon number 3. There we go. Alright, so we have this here. Let us fill in all of the extra spaces with hydrogen atoms. And we don't actually have to write out the H's. We can just put little dashes and understand what that means. These are bonds where there are hydrogens attached to them, like so. We could also draw the skeletal structure for this. Okay, so the skeletal structure, remember there's a carbon at the end of each line. So here's the first line, here's the second line. So I'll need 1, 2, 3, 4, 5 lines going across here. 1, 2, 3, 4, 5, like that. And then from carbon number 3, 1, 2, 3, right here, I need an ethyl branch going off and another ethyl branch going off. So let me draw something like this. Like this, perhaps. Okay. So here's one ethyl branch, and here's another ethyl branch coming off of carbon number 3. So there is a skeletal structure for this one. There's 3,3-diethylhexane. Alright, let's have some fun now. Let's draw 2,3,4-trimethyl 1,4-pentadiene. Okay. Let's start out with our main chain. Our main chain here is 1,4-pentadiene. So penta, there's 5 carbon atoms. 1, 2, 3, 4, 5. Okay. There are 2 triple bonds, and they're on carbon numbers 1 and 4. So let's say this is carbon number 1. Did I say triple bonds? I meant 2 double bonds if I said triple. So one of them is here on bond number 1, and the other one is on bond number 4. So 2, 3, 4, right there. So there's my main chain, 1,4-pentadiene. Now I need my branches. There are 3 branches, and they're methyl branches. They come off of carbons 2, 3, and 4. So a methyl branch has only 1 carbon in it. So let's find 2, 3, and 4 and put methyl branches. So here's carbon number 2. It's got a methyl branch there. Here's carbon number 3. It's got a methyl branch there. Here's carbon number 4. It's got a methyl branch. And then we'll go through and we'll just put the hydrogens. So here, this is 1, 2, 3, 4. 1, 2, 3, 4. So he doesn't need any hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. So he doesn't need any. And 1, 2, 3, 4. So there's the Lewis structure. Let us draw the skeletal structure. Okay. So here we need 1, 2, 3, 4 lines. 1, 2, 3, 4 lines. Okay, and I need another line, an additional line coming off of 2, 3, and 4. So here's 2, here's 3, here's 4. Okay. I have a double bond here, which means I need to double up the first line, and here, which means I need to double up that line. And there is a skeletal structure for this one. That was 2,3,4-trimethyl 1,4-pentadiene. Alright, let's have a look at 6,6-diethyl 2,4,7-decatriene. This time we've got an alkyne, we've got some triple bonds there. And you know, once you're used to the rules, it really doesn't matter how long or complex the name is. It's all the same. I mean, we could draw pretty much anything as complex as we can make it here. Let's start with the main chain. Deci means 10, so there are 10 carbon atoms in this main chain. Let's start with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We've got triple bonds. There's 3 of them on bond numbers 2, 4, and 7. So 1, 2, 4, 5, 6, and 7. There we have our triple bonds. Okay. I have 2 branches, 2 ethyl branches. The ethyl branch contains 2 carbon atoms, and they're both coming off of carbon number 6. So 1, 2, 3, 4, 5, 6. Here's an ethyl branch, and here's another ethyl branch, both coming off the same carbon atom there. And then let's go through and add our hydrogens. So this one needs 3 more. This one has 1, 2, 3, 4 bonds already, so it's good. This one has 1, 2, 3, 4 bonds already, so it's good. This one has 1, 2, 3, 4 bonds already, so it's good. This one has 1, 2, 3, 4 bonds already, so it's good. This one has 1, 2, 3, 4 bonds, so it's good. This one has 1, 2, 3, 4 bonds already, so it's good. This one has 1, 2, 3, 4 bonds already, so it's good. This one has only 2, so So let me add 2 more. And this one has only 1. 3 more there. And then the ones up here. And the ones down here. And there we go. Notice we went all this way without adding any hydrogen. That was pretty neat. Can we draw the skeletal structure for this? Okay. So I'm drawing the skeletal structure. I need 1, 2, 3, 4, 5, 6, 7, 8, 9 lines in my main chain. Let me try to squeeze it in down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's see, the second one is a triple bond. 4th one is a triple bond. 4th one right here. And the 7th one, right, is a triple bond. 4, 5, 6, 7. Okay. Now let's figure out our branches. They come off of carbon number 6. 1, 2, 3, 4, 5, 6. They come off right here. Let's make this go this way. Make this come off this way. There we go. So there's a skeletal structure for that one. That one was 6,6-diethyl 2,4,7 decatriene. Okay, so there were a few of these branched hydrocarbons that are a little bit more complex than some of them that we did in the last lesson. They're really, no different. They're just some of the more complex ones. Have multiple branches, different kinds of branches, double and triple bonds, mixture of those things, In the next time after this, we're going to take a look at what happens if we have some things attached to our organic molecules that are not carbon or hydrogen. So, until then.